Turn the mic on. Is the mic? Yeah. I'm seeing levels there, so that's good. Where's my cursor? All right. I am back after 3 weeks of stupid travel. Feeling a little burnt out, but I got some time off now. September, October, November is going to be insane, but GopherCon London was great. Great talks when they come out. Almost every talk I thought was worth everybody's time watching. I'd say most of the US talks were also pretty good. I feel like they were batches that I got stuck doing something. I didn't see something. I didn't see all of it, but it was single track, which I thought was awesome. I'm gonna have to get you there next year, bro.
I want to go. I was gonna say I want to go definitely to a conference and just see what that's like.
Yeah, and I don't know where the US one's gonna be next year. It might be in Canada, but we'll get you to one for sure.
Cool.
All right, so what are we gonna work on today? Well, I was thinking the following. You had worked with Florin on some stuff, which I'm going to throw all that code out because while I was with Florin in New York, we rewrote a lot of that to have training material. So what you see currently under example 12 is going to be deleted this week. What you see under 13 is going to be 12.
Okay, you got it.
And ideally, I don't want to build a product where it's like a consumer product, but we need to build an internal product. Allie just came in. Like the dog. Hey, dog. This is a live show, man. This is what we do. Max has been getting shots for his joints, so he's turning into a puppy right before our eyes.
He's all
I'm wondering why. I'm wondering, it's like he was slowing down. It was like great, man. And now this dog is like 9 years old, but he acts like a puppy again, and I'm like tired, man. So the bottom line is that I'm gonna go through the code that we hacked on one more time. Just I gotta familiarize myself with it.
Yeah.
But we need to build an internal product so we could take all of our videos, both what's behind the paywall and what's in YouTube, and create. There's two things I want to do. I want to create a chat system where people could actually get information out of the videos, including code that we're showing on screen, diagrams, sort of all that stuff.
Okay.
And we'll do this with the service too. The biggest problem is these videos are really large. So how do you process the video?
Yeah.
But minus all that for a second. If I could take the entire service class, okay, and I know how I want to chunk it up, and I can parse the translations and parse the code and parse all that. And I've got a proof of concept. We're going to go through that. But if we could do that for the 20 hours of video, right?
Yep.
Not only do I have a chat system where after somebody watches a class, they could go back in and index into stuff and ask questions and get what they need.
Yep.
I want to take all of that and ask the LLM to write the book.
Oh, okay. That's cool.
Right?
That's cool.
Write a first sort of version of a book for this class. And then I could go in and clean it up, right? But
that would be
but there's no
another
reason why I
level.
couldn't do it, right? I have everything I said in the order that I said, diagrams and code, like lay that in somehow. Like that to me is the ultimate goal. And we can experiment this with certain amount of video sort of to start anyway, right?
Yeah.
So that's what I'm going to be sort of working on. Now, another thing I'm trying to do is get some members of the Go team, which at GopherCon, they agreed to come on the show, even though they're frightened to do any live coding, which cracks me up because you're like on the Go team.
They're like, yeah, they're major leagues.
Yeah. So like I said to Alan Donovan turned whiter than I've ever seen him. Alan Donovan works on all the tooling. So I want him to come back and help me improve some of that Go edit tooling that we did. So I'm going to bring him on for that. Robert Finley, who works like on the Go runtime and stuff, he said he'd come on the show too. I got to figure out what to code with them. So I'm going to think about that before, like Robert's not going to work on this stuff.
Yeah.
But I got to think of some stuff. The other option also is to put something out there. Maybe we do this anyway for people that are watching the show. Put out a form where they can kind of say people they'd like to see do 2 hours of live coding and some ideas around what they could sort of hack on.
Okay, yeah, that's a good idea.
I will never share that with the guest because I like that sort of raw moment. If you're too prepared, then
yeah. If you're too prepared, then it's
it's not right. You know what I'm saying?
Yeah, you don't get.
And I've told them. I told Alan what we were going to do, so that was fine. But like Robert, I was like Finley. I'm like, I ain't telling you, bro. You're just going to come on. We're just going to hack on something. But I'm not going to do any pre-work either, so you're good.
Okay.
Anyway, I think we should put a form out there and see what we get. I bet you John Amsterdam would come on as well. He's working on all the MCP stuff, so some of that might be interesting.
Yeah.
I don't know. Anyway, we'll see. I don't know how much time I really have between now and the rest of the year for me to continue to be on the show anyway. But we'll see where we're at. So I want to go back through 13. I even have some diagrams, I think. So hold on a second.
There it is.
I don't know. That was weird. I must have hit the wrong button. And we muted for a second, but we're back. We're back. Okay. So if I bring up the project, I think I had AI. Oh, I did it under 30. So 12 is going to go away and 13 is going to be 12.
Okay.
And I put this together for Florin when we were sort of talking. And let's go through this because this is my sort of ultimate goal. And we've got 3 steps of code that sort of make this happen already. Then the question is, how do we turn this into, again, like an internal sort of product and do this right? So here's the idea. I took down 45 minutes of video, not output, right? Training. And well, obviously I wouldn't have put it in there. Where's the video that I took? I have to look at, let's take a look at this for a second. Hold on. I got to make sure. It was a big video I took off of, yeah. Okay. So this is 1.3 gig. This is test rag video. I wonder if I can like bring it up. That'd be kind of cool if it came up. Well,
there it is.
You could do that.
Nice.
So there's 35 minutes of video here, right? So this is one of the lessons from the ultimate software and design and engineering.
Okay.
So you can see here I got code. I don't know why we can't hear it per se, but whatever, it doesn't matter. So this is one lesson here where I guess I'm teaching about authentication middleware.
Okay.
And you can see all this code that's on the video, right? And I can't hear me talking on this for some reason. This could be a VS Code problem, but you got terminal windows, you got code. My guess is at some point you have me too, which I don't see. Interesting. I thought I'd even be right there in the beginning. But you can see different things. Okay, so there's me. Look at me. I weighed about 145 pounds there. Man, I was going to yoga every day. But you have all this, okay, with sound. So here's the idea. We have, I don't even know how many of these videos that we have, right?
A lot.
We have a lot of them
Yeah.
for an entire sort of class. This is one of them. So I pulled this down off of Thinkific, where
Mhm.
we keep everything. But you can see it's like we probably have 30 of these videos or something at this size.
Yeah.
Just
Definitely.
downloading them and putting them somewhere is already going to be sort of interesting. So obviously I'm not putting this into the GitHub repo, though one could argue now that they have this file system, shared file system, so it's not part of the actual repo. They have limits now. I think it's like 100 meg. You can't upload anything more than 100 meg without
Okay.
attaching it to some shared file stuff. I don't remember what we did there, but we're going to clean up some code. So here's the, oh, actually, this is our, I don't know where it should, I'll just keep this down here again.
Yep.
Okay. So let me go back to the Excali draw. Hold on. All right. So here's the idea. I have a, this was like 35 minutes of video, right? But I have a 45-minute video. So the first thing I want to do is break it up into chunks.
Yep.
Now, I was trying to think, oh, I'm just going to get rid of anything that is sort of in here right now. So I was trying to think, what would be a good chunk size of video, right? Because this chunk is going to be basically your index. So I was thinking about Netflix or any video streaming.
Yep.
What they do is they create 10-second files.
Yep.
And if you've never realized this, if you fast forward or rewind on, say, Netflix, you'll see that you get a keyframe for every 10 seconds. Look at the, right, 0 to 9, 10 to 19, whatever that is. And actually, they literally have files for every 10 seconds that you could actually, it's all public there at some level, right? So you could go down and build your own streamer by just pulling down these 10-second files and having a cache of them ready to be played ahead of your time. So if we did 10-second files, then there would be 6 files for every minute of video.
Yep.
And my brain went, I feel like maybe that's going to be too granular for what we're trying to do. So this is my, and I'm not saying we're going to end up here, but my first attempt here was, you know what, let's do 15-second chunks.
Okay.
That would be 4 videos a minute.
Yep.
And then that would be maybe just a couple hundred videos, files for every 45 minutes of video, let's say, right? And I thought there could be enough context. Like if we go too big, it may not be, this is the chunk problem with RAG, right? You go too small, there's not enough context to sort of hook into.
Yeah.
If you go too big, there's too much. So I said to Florian, let's do 15-second. So the first idea is you're going to take this big video, right? Our test RAG video, one of my lessons. And we need to break it into files of 15-second chunks.
Okay.
Now, there's a program that everybody has, or we can install it with Brew, which I've done, called FFmpeg. And instead of trying to find C code or Go code, that uses C libraries to do this, we could just shell out. And this thing does so many things that we need.
Yeah, it was pretty cool. It was pretty cool seeing that work.
So we've got the commands for that. So and I'm kind of calling it sort of step 0 only because it's not necessarily Go code. We're just going to shell out. But the idea, and we'll look at the code in a second, is we're going to call FFmpeg to create these 15-second files. Okay. Then we're going to consider each one of these a chunk that we're going to process for a 45-minute video. Now, the next thing is we have video. Video is made up of images, but there's always one image that's the keyframe. That is a full sort of image of everything. Okay. And then you have what we would argue are diffs. Okay. And then you'd have another sort of keyframe. And it's the same thing kind of the way video is streaming. You get a keyframe, you get a bunch of diffs, so you can do that. That all has to be within a certain cadence of time. And then you get another sort of keyframe. So like when you're watching a sports program, usually it's really clear because if you watch American football, everybody's standing still for long periods of time.
Yeah.
And then there's action. And sometimes if too much is happening on the screen, things start to get a little blurry because
Yeah,
there's too
which you
much
see that.
change going on, right? But the idea is we can go and extract the keyframes out of that video. Now, it's unknown on how many keyframes there's going to be because it's unknown how much change is happening in the video.
Yeah.
So after we extract the keyframes, what we noticed, and I'll show you this in the next step, is that some of the keyframes look really the same. So
Yeah.
maybe we extract 20 keyframes, but as you start walking through them, it's like this one's really similar to this one. It's the same. It's the same. Then it's changed, and then it's the same.
Mm-hmm.
So we're going to need to use a LLM in some sort to be able to extract when a keyframe is literally different from the next image.
Got it.
All right. So we've written some code. We're going to go through that. And the idea is to try to just keep the pure, unique sort of keyframes that we have.
Yeah, where there was a change.
And there's really sort of 4 categories of keyframes that we want to keep. Code.
Yep.
Diagrams.
Mm-hmm.
There could be a terminal window, which I don't particularly care about if we're in the terminal. I don't care about the terminal. And then something I'm just going to call other, which is sort of everything else. I don't have to keep me. What I want to keep is anything that's like a diagram and especially code.
Got it.
So once I've got the unique keyframes, I've got the unique code for that 15 seconds. The next thing is I can take the full transcript of that 15-second video, and I have that.
Okay, yeah. So that was one part that I was wondering about this whole thing, is how you were gonna line up the transcription with that same sort of chunk.
We're going to do it with the 15-second chunk, right?
Yeah.
So each one of these will have a transcription. But we know the transcription isn't great. It never really, it assumes that you're seeing things. It's like TV. If you're a radio guy, then you have to describe everything because you know nobody can see anything.
Yeah.
But if you're a TV guy, it would be horrific to do that. You're filling in the blanks on what somebody's seeing.
Yeah.
And that's what this transcription ends up being. That's why our first attempt on ardanlabs.ai to take service didn't work.
Yeah.
Okay.
Yeah.
So we can use FFmpeg to do all of this, and we will, right? But this is an important part too, because once I've got the chunk, right? I extract the keyframes. I find the unique keyframes. Now what I want to do is get a description and a classification for each keyframe. That description gets bound with the transcription. So there's more context there.
Okay.
Right?
Yeah.
But the idea is I can also use the description to compare the keyframes to see how. Now, this was before we could find, so we had problems. We couldn't find an embedding model that would run locally that we could use for a compare. So this was a nightmare for us. We tried everything. There is no vision model for Ollama, that embedding vision model for Ollama.
Okay.
We couldn't find one.
Yeah.
Then we couldn't find one for VLLM. Then Florin, because Florin doesn't give up, found a model with some Python code that would do embedding with images.
Okay.
So suddenly now we were able to not rely on descriptions. Because first what we were doing is, because we didn't have an embedding model for an image, we said, okay, let's use the LLM, give it the image, and tell him, give me a description of the image.
Yeah.
With a very low temperature. And then give me a description of this image. And then what we would do is embed the descriptions and get a similarity score.
Okay, yeah,
if the descriptions were similar, then the images must be the same.
Yeah.
But that was taking forever. And Florin and I looked at each other and we were like, it's not going to work. What we really need is we need to be able to get an embedding for the image itself, because that would be fast. And then we could basically do a cosine. Oops. What did I just do, man? Then we could do a cosine. Okay, Mr. Kennedy. Similarity, right?
Yeah.
That's what we really wanted to do.
So
Create an embedding
yeah.
and run the cosine similarity ourselves. I didn't need a vector database for that. I've got 2 points in space. I'll show you how Florin figured out how we can run an embedding image model to do that. And it's sped up like this. So now we can very quickly identify which of these images are unique, which ones aren't.
Got it. By comparing the image themselves rather than the description. That was
Technically,
like
right?
the main.
Because we're getting an embedding vector for the image.
Okay.
So that was the way to compare the images.
Yeah.
Embedding
Rather
vector.
than generating a description, then doing
It worked,
comparison.
but it was forever, right?
Yeah.
So now the idea is to keep the unique images based on the similarity score. So we figured that out. Then once we've got the unique keyframes, now we can extract the code. And this also did classification.
Okay.
And it worked really well. So then we extract code from the images that have code. That becomes part of the embedding text too.
Okay.
Right? You got my transcription.
Yeah.
You now have code. And then we can also get descriptions of the images anyway at that point. That's still a little bit slow. So when you think about what we have when this is all done, is for every 15 seconds you have a transcription.
Mm-hmm.
You've got a set of images that we know are unique. We only have to keep code and diagrams.
Yep.
So we do that. Then we extract the code and put it into our document for that chunk. We get descriptions of the images. We put that into our content for the chunk. And then we create an embedding for that chunk. So in Mongo, we'll have the embedding for the chunk, the actual content that we've embedded, the set of images. I don't know how to do that yet, but some sort of blob for the set of images for that chunk. And then a file name for that chunk with a timestamp. So we know where that is in the larger sort of video.
Okay.
Because ideally, when that chunk is going to be used to answer the question, we could provide a link to the larger video with the timestamp on where that started.
Got it. Okay, and it'll be the start.
Yeah, you could always rewind back if we're not, but it will be the start of that 15 seconds. You're going to be really close.
Yeah.
As a user.
Right. And it should have good context because it has description, classification, the image itself, like
and everything in it.
Yeah, I mean, there's
even if we're off by 15 seconds, you're going to find it.
Yeah.
You may have to go back a minute, but you're there.
Right, yeah,
to get the full context.
Exactly.
So this is the idea. All right. This is really the idea. So I guess below the line, I wrote everything again, right? Create chunk files. Then for each chunk, we do sort of all this stuff. We didn't finish all of it. Like I didn't do the Mongo piece, but we did do at least 3 steps of this. So let me save this for a second. So I want to go back and look at what we did here in terms of steps and sort of run that. But you're going to see now we have a new command called embedding up. So there's no Mongo here just yet, but Olama up, embedding up. What the embedding up is going to do, instead of using VLLM, we added this embedding folder under command. So basically, Florin went to Claude Code and said, I need some Python code that can run this model.
Got it.
I think that's what he did here. Now, the only reason that would happen, I think, is I always forget about
the
Python interpreter, right?
Yeah. Interpreters.
I don't want to clear. I don't remember.
Select interpreter.
And it should be this project here, which is AI training. So I swear all this is running though. Oh yeah.
Yeah, there it is.
Okay.
There it goes.
Yeah. I have the virtual environment here. So I know I ran everything. So Claude Code gave us this. I'm not even really reading it, but it allowed us to now run a model server that can do embedding for images.
Okay.
Dude, I don't know. It uses fast API
Yeah.
to create the endpoint, and he just put it in here and it worked. And we just looked at each other like, "Thank you,
Nice.
God."
Yeah.
So for anybody kind of bringing the project in, you got to do the Python install, which creates the virtual environment for 3.1.12,
Using
and
UV.
reads the requirements document, which is everything that we need to do that embedding model. Sort of right there, puts it all in the virtual environment. And then obviously we have these models now. So this is the model. No, it's a thinking model. Which model are we using again for this? This nomadic embedding vision. There's a way to pre-pull this model down to, I have to ask Florin that again.
Oh, because it's not like on
It's
a.
not an Olama, right?
Okay.
So it's not an Olama thing, but we're also now bringing in FFmpeg. But the install sets up the virtual environment. We've also added some environment variables here related to Olama, increasing the context path. You can see we increased that there, but this embedding up, it will download the model for the first time, and it puts it somewhere in your user folder dot something. I don't remember. We can go look, but we're going to run that. Also, to speed up Olama, though I feel like I'm not running as well as I was before, we've made some of these, and I don't understand all these settings here, but the flash attention helped a lot with performance, and switching to floating point 8-bit numbers. Max, are we done drinking yet, bro? Hi. Sorry. Max has decided he's going to drink a gallon of water right now. Okay. So switching to like a smaller floating point number and setting this attention.
Okay.
This helps speed things up. But remember, you start to lose some accuracy as you begin to do this. He wanted to switch that to FP4, and I screamed, "No, we're not doing that at all. Stop." And we're not going to be using VLLM. I was hoping we could use VLLM, but we're not going to be using it. Okay. And then I added some FFM samples like I do with curl, just so we can see it.
Okay.
Okay. So bottom line here is I need to have Olama up. Let me at least bring that up. And then here, I'm going to run the embedding up, which will run the other. Oops. Sorry, everybody. Do that occasionally. Now you don't want to come back up. Mr. Kennedy, why do you... I don't know. I must have... Why didn't it... You gotta be kidding me.
Maybe hit it.
Normally, I just press it again when I hide it. Okay, here. Windows style. I've hit a button.
Arrange windows. Or bring all to front, maybe.
Where do you see bring all to front?
On the bottom. No.
No, that didn't work.
Or right click that and then hit up there.
Whoa.
There we go.
That's some new stuff. Sorry, everybody. I have no idea what I hit. Oh, double make is not going to work. Here. So this will bring up, we'll run that Python code I showed you. And I've already downloaded the model.
Okay.
But this nomadic embedding vision model will let us do that piece. So now we're running there. Gosh.
I wonder why there's not like an Olama option for an vision embedding.
I don't know, dude.
I feel like that would be
technical about it, right? Like, remember, like there are large language models, there are vision models, there are math models, there are, right? And so Olama is really focused on those large language models that have reasoning and can do that. But like vision models are probably a completely different sort of universe.
Hmm.
And they have vision models for chat. They just don't have them for embedding. They have the text embedding models.
Oh, okay.
Whatever, bro. Just
Yeah.
right. And
February.
even for VLLM,
Mm-hmm.
right, which is what we run in production, they didn't have a vision embedding model. So at Prediction Guard are embedding the bridge tower. I think that runs with the TEI server code. It doesn't use VLLM.
Hmm.
Right? So it's just like this code is set up to, in fact, the Python code is there. Like you could literally read it and maybe understand a little bit more. I don't think I ever want to go to that level, even though we've got the code there. All right. So step one, it shows you how to process full length video into chunks and extract all the information for each chunk. So I got to kind of get familiar with this again. So I did a couple things too to the samples, because when we were teaching this stuff in training,
Mm-hmm.
there were people that couldn't run anything on their machines. So what we did is we had people connect to Florin's MacBook,
Oh, okay.
right? Because he has a MacBook now,
Yeah,
like
yeah,
that
yeah.
can connect in the class. But that required them to sort of make code changes because I had hard coded everything for localhost.
Hmm.
So one of the things I did in all the examples is the URLs for localhost can be overwritten with some environment variables,
Okay.
right? So they're
Yeah.
there if you need to do that. And now students can sort of set that in their terminal
Okay.
and do that. And then again, we've created some pack or program level variables just for things. So they're just not hidden if we're going to change it. So our
Yeah.
source directory is zarf, samples, videos, and source file name. In this particular example is this training MP4.
Yeah.
I don't know how big the training MP4 video is. So that's 5 meg for a test right now. And it's only 7 seconds of video, right?
Yeah, that's the one that's committed.
It's 7
Sure.
seconds of video right now.
Mm-hmm.
So we'll play with this, but we really want to sort of run against that. Okay. So we've defined a structure, file name, description, embedding, some basic stuff here. We're creating 2 new clients, one for the chat model, one for the embedding model. Because our client is OpenAI compatible, right? We're not tied. It doesn't matter. All these model servers sort of support this API, which is great. All right. Let's just look at the high level thing here. So we're splitting videos into chunks, 15-second chunks. We'll look at that. And then we're going to have all of that on disk. So we're using the walk directory function.
Okay. And walk directory is
essentially, I'm looking for the run on that. Where is it? This is why I like to assign these things. Okay. See how confused I am?
Mm-hmm.
I'm going to fix this. This to me is you're being too smart. This is why I was confused. So walk directory says, given a location on disk for all the files that are there, dot, okay, for all the where the root is,
okay,
execute this function for every file.
Okay.
See, Florin embedded the function in the API call, so I got confused. I always like writing code like this. Here's the function we're going to execute, and we pass it in.
Got it. Okay.
That's where I got confused. So basically, for every file in the directory, and that directory is going to be what we put up here, right? Videos.
Videos. Yeah.
Source file name though is training MP4. So, so I guess we're going to dump everything here in videos. In fact, video chunks. So we're going to have a bunch of files under chunks.
Okay.
If it doesn't have an MP4, get rid of it. We're not going to look at it. And then he wrote a function called get video duration. And that's so we can have the timestamp. The problem is, even though we're asking FFmpeg to do a 15-second chunk,
Okay.
Some chunks are 14 seconds, some are 16. It's not
Hmm.
exact.
Oh, okay. It's
So we couldn't just blindly go, well, you're chunk 0, so you're at 0. Oh, you're chunk 1, you're at 15.
15. Yeah, you
I
can't.
was hoping we could do that, but we couldn't.
Mhm.
So we have to really know the length of that video, or our timestamps get skewed over time.
Oh, okay.
All right. Then I don't know why he did this with a defer, to be honest with you. Defer the total time computation until after processing is. Oh, I guess because duration. I honestly don't know why he did this. Why defer total time computation until after processing the chunk? Maybe he needs this information and he wants to do it after the call to process chunk, is my guess. It's not 100% clear,
Okay.
but he wants to put this on the return. And so he'll say, do this after this function. That's my
Got it.
guess.
Okay.
And then he's processing the chunk. I'm giving it the chat, the embedding clients, the source directory, the path, total frame time, and duration. So he's giving it all that information. And then walk directory will just walk through every chunk.
Got it.
All right, this is a Go sort of API for things. So that's your basic run here. This should get us all the information for the training video. I don't remember how many chunks. Now, extract frame info prompt. So it looks like we've got a prompt here. Provide detailed description of the image. So this must be when we're getting descriptions, right?
Yeah.
I didn't want it to take forever because this can take a little bit long. So I tried to say, give it 300 words or less. This is where we're asking it to classify it. This is where the LLMs are amazing, right?
Yeah.
Like I have to teach it this. They've already been taught this, and they do an amazing job knowing what source code. Like it's still mind blowing to me that the models can do this. It's made life so. To try to program this,
oh, that would be a
is
nightmare.
impossible, right? So we're telling it what we want in terms of classification.
Mm-hmm.
We also noticed that there were times where I was screen transitioning, like on the Mac, and you see all the apps. Nobody can see this in the stream, but if anybody hits Command Tab right now, you'll see, at least on the Mac, all the icons for all the apps.
Exactly. Yep.
That was coming up on some of the keyframes.
Oh, yeah, because
I don't want to keep that because it was blocking the source code.
Exactly.
So what this is saying is, if you see icons present in the middle of the image, in other words, somebody hit Command Tab and that came up, we're just classify that as an icon because we're going to throw that away. We can't use that image, right?
Got it. Okay.
And then we want this sort of JSON output. And then just some other things that we sort of
And this prompt is for that vision embedding model.
no, this would be getting a description.
Oh,
not
okay.
for an embedding, because we
Okay.
wouldn't need, you don't need a prompt for an embedding. You just give it some text.
Okay, got it.
Okay, so let's go and look at this function first, though. Split video into chunks. So not much going on there. It's literally an FFmpeg call with settings that Florin somehow knows. And it basically generates... I don't wonder if he's hard-coded. I wonder what that does. Oh, that's an error. I feel like he's hard-coded the file that we're going to be... Here's the source. Are we using source here at all? We are here.
There. Yeah.
But %s. Okay, so here's the source. And then he's running this chunks. I don't know what this output MP4 is. It's almost like it's this thing. I have to ask him what that is. We're doing log level error, but we want the chunks in this chunks folder. Or maybe it's going to put it in the chunks folder with this naming convention. Okay, so
makes sense.
We're going to run that, but it should generate the chunks in here for this video, right? I think that's what that's doing. And then we've got get video duration. So he's running another program. Oh, I wonder if I have this program loaded on my machine.
Probe.
I do. So that came in. I don't know if we put that. Hold on. I don't know if it comes with FFmpeg or maybe it comes with FFmpeg.
As like a dependency or something
Yeah,
when
because
you install
if
the
I
brew.
do a history grep, yeah, I never did a brew install on that. So my guess is it must be coming in when you do the FFmpeg.
Yeah.
We must be getting it for free. All right. So it looks like he's running this probe, which is giving him the duration of each video. So that's fair, right?
Mm-hmm.
Okay, sweet. And then let's go back to process chunk. Okay. So a lot going on here.
Yeah.
Okay. So Glob returns the names of all files matching this pattern.
Or nil.
Interesting. So given a source directory, I didn't even know this function existed.
I've never seen it.
It gives us all this. And why does he call it previous frames? I don't know why. We'll have to ask him. Now we're going to iterate in a tight loop here, previous frames. And he's going to remove any previous frames one at a time. So it looks like he's looking to see if there's any files already in the folder under this frames folder. And if there are, he's one by one. You would imagine there's a better way to do that. So we'll have to ask him. He's getting rid of that. Then what he's doing is he's extracting the keyframes from the main video.
Okay.
This is the one I'm interested in. And again, it's just an FFmpeg call. So the chunks will be the set of videos. The frames will be the keyframes for each video, using that same sort of naming convention here, using FFmpeg to do that with these particular parameters. Okay, that's fair. Then once he extracts that, he's getting the set of files from that folder. He's creating a slice with the capacity of those files, calling that frames.
And why is he doing it to the to the length
yet.
of files?
Okay. I don't know yet. You do this if you want to use an append.
Okay.
But like I said, let's take a look at why he's doing that.
Yeah.
So we're going to iterate over every file. He's defining what a frame is based on file name, total frame time, and duration information we have already. He says, okay, we're going to process this image. We're going to read that image in, which is probably just a read all.
Okay.
We're going to, but we'll also get the MIME type. The image is a slice. And then he's going to copy those bytes into here. That feels wrong to me. I don't know why he can't just do an assignment here.
Okay.
Why copy millions of bytes when like for me, this is better.
Rather than, okay.
Right? Because I already have the slice. It's already been created. It already has its own backing array. So I would say to like Florin, why did you do this? This change I'm about to make is going to save us a tremendous amount of memory and time.
Okay.
Because I already have the slice, which already has the backing array. I can just assign it to F, and it's like, I don't know why it needs its own copy of bytes.
Okay.
Because I am sure if I look at read image, it's constructing its own slice of bytes. It's already a unique slice with a unique backing array. So I would say that this is not necessary.
Got it.
At all.
Okay.
So I'm going to just comment that and ask Florin in a little bit. We still don't know what's happening with that just yet. Okay, so we have an image and we're in this loop. Now we do the embedding with image. So that's going to hit our embedding server, which is right here. Get us an embedding back. I'm going to log just the first and last 3 numbers so we see it.
Okay.
Now, once again, he's doing this copy. But I would argue, once again, right, that this is a waste of time. We don't need to make copies of this. This is already going to be a unique memory allocation for us.
Okay.
So I think, I honestly think he's wasting time here. I'm going to just comment it out and ask him. But let's do that instead. You see how more efficient this is going to be.
Yeah.
Now he's appending the frame, but the only reason we may not append this frame is because of some failure here.
Okay.
So this is the only potential failure that you can, oh no, we can do this fail. This fails too.
With the embed.
Now, however, if that fails, we're returning. We're done. We're not like continuing on. So this doesn't make sense to me that he's doing this with append. What I would do is he's allocating memory and then he's just appending into it.
Yeah.
But we don't necessarily need to do that. We have I here. This would be much more efficient if we just index into it, right? As opposed to calling a function like append that still has to do a bunch of extra sub CPU. This is O1, right? This is just bah, go in it. You would do what he did. And even that, you wouldn't necessarily say. You do what he does when you don't have an index.
When you don't have an index.
So when would you not have an index? When you're iterating over a map.
Map, yeah.
Ah, you said it before I did. When you're iterating over a map, you don't have an index.
Yeah.
So now you would set the length to 0, the capacity, and you would use append.
Okay.
Right?
That makes
Instead
sense.
of creating another counter variable.
Yeah. Yeah.
Right? From a code perspective, it's a little less code. But this isn't a map. This is a slice. We have an index.
Yeah.
So use the index. Right?
Okay.
Now remember, I'm not trashing Florin here. Florin was hacking. When you're in hacking mode, you're just trying to get code to work.
Yeah.
We weren't in engineering mode. We're doing a tiny bit of engineering right now because we're trying to understand the logic a little bit, right? So nobody's to look down on I would have made maybe the same decisions in that draft of code.
Yeah, we're looking in hindsight.
This is our second view of it, right? So, but Florin also may have had a reason that I don't see. So we're going to leave these comments here, but I don't think this was necessary. At least right now, I don't see it. Sometimes I don't think something's necessary. I do this, I run it, and the code doesn't run.
Yeah.
And I'm like, whoa,
hold on.
What did I do wrong, right? This is why he made a copy, but he didn't leave a comment. Okay. So I think this is cleaner, right? Now, this ends up giving us MIME type, images, and embeddings, right? Now, I wonder if you think this is more readable. Let's have a readability conversation for a second.
Okay.
I'm very much against what he's doing here. I try to teach, don't do partial construction. It's going to hurt you and it hurts readability. So I'm going to do something. See, he shouldn't be doing this. This to me is bad. And this is a conversation I do want to have with him. Don't do that. Construct this value or object when you have everything you need for it. Wait until you have everything you need. So, in other words, we now have these two things, right?
Yep.
I know that's wrong. Oh, thank you for AI. I also know that we have this thing. And so what we should be doing is using local variables here.
Okay.
Local variables here.
Mm-hmm.
And then at the very end, construct the object or the gorilla, as you know I like to call it, with the banana, as opposed to a partial gorilla. Partial gorillas are going to kick you in the butt every time. So he created a partial gorilla and then he started feeding it. That's going to cause problems one day. Maybe not here, but at some point you might return that partial gorilla out and you don't realize that, oh my God, it wasn't really holding all the bananas. It shouldn't have been. This is always going to be safer and it's going to be more readable because we see that at the assignment, at the time of the assignment, you're constructing the gorilla and you're doing the assignment. You see, we have much better readability and the code is much more compact, right?
It is.
If I were to just get rid of this for now, and I have it in the change set. So let's see, how much tighter is this now without those little F dot sort of spots.
Exactly.
Sort of somewhere.
And this looks more familiar too.
Yeah.
With the normal.
You get a complete picture of what's happening here. Yeah. Right? These are the things in a code review you're looking for, right? You're trying to help with readability, but it also helps with integrity as well. So you're reading the image, you're embedding the image, you've stored all those local variables. Then at the end, you come in and you do this sort of assignment.
Yeah, that makes sense.
Much cleaner, right? The problem is that we're going to have to go back and clean up step 2 and 3 because it's going to take all this code.
Okay.
Which is the nightmare when you're doing this for training.
Yeah, you're doing the same thing over.
So we're going to clean some of that up. Okay. So now what does he do? So now we've got all these frames. We have an embedding for each frame. We've got all the information, but we're not going to be able to keep all these frames. So what he does next is, notice here he creates a 0 slice. And to me, that's the right thing to do here. Create the 0 slice. Because he doesn't know how many of these he's going to keep.
Okay.
Right? He knows here he's going to keep everything. But here we don't know if it's going to be 1. Well, hopefully he can keep 1 or many. So this is, right, we're just going to have to take the little bit of the memory bounce, but that's okay. Now, I would say that he let AI name this variable. As a Go idiom, we don't really use index here. As a Go idiom, we use I for that variable name. Now, another thing I would say is F isn't good here. It's not necessarily an idiom there. F for me is like a function or file. Okay. So like in those APIs. So my brain immediately went to sort of file. Now he did call the collection frames, which I like, right? Use that plural. And so when you're iterating over frames, you get a frame. Yeah, it's going to read much better like this. F has too much baggage in terms of file or function or something like that. Yeah, this is more clear. This is much more Go idiomatic and sort of clear here. So this is code we're going to clean up. Now, if I is 0, he's auto-magically keeping that one and continuing back. So that's fair. Now, he knows he's going, so this is interesting, right? I would say this is too much of a pre-optimization. It doesn't matter. Okay. But if we know we're going to keep at least 1. Okay. One could argue that we could have set the length of this to 1 immediately. That being said, that's assuming that we have frames at all. You don't want an empty sort of frame here. Yeah. This will never show up in a profile, so I wouldn't want to do it. But you could decide that if length of frames is greater than 0, then start with a length of 1 or capacity of 1, I should say.
Capacity. Okay.
So, or we do index in there directly, just in case that if you're only ever going to keep the 1 frame, you've eliminated any sort of allocation there.
Got it.
But this isn't our problem, really, at the end of the day, right? This little allocation that's going to take place.
Yeah.
So we're going to be fine. But you see what's sort of happening there. Like this is a guarantee, almost.
Basically.
And I can't imagine that we're not going to have frames, right? Like, what are the chances that we're not going to have frames if we have video? For me, the chances are slim to none.
Yeah.
I don't know how many I'm going to keep.
Because it's named unique frames, but it's like it's not it's asking if you have frames in general, but not like a unique frame. Like you could have 15 seconds where it's on the same.
There's no way we're not going to have a frame. There's
Okay.
just no way. I have video.
Yeah.
There are images. It's going to be a frame, right? And so I could argue that that's a guarantee, right? That's a guarantee. Now somebody's asking about, isn't a frame a type? A frame isn't a type in the sense it's data that is representative of this structure. So it's data. There's no way we're not going to have at least 1 frame, right? If that worked, we're going to have 1 image. There's just no way around it, right? A frame is essentially an image that we've now taken, embedded, all of that. Remember, right? For a given file, we read that chunk in.
Yep.
There are, we read the image in. Let's go back to this for a second. So for a given frame, actually now I'm confused again. Process a chunk. A chunk is a 15-second video.
Yep.
We cleaned up those files down there, so I don't care about that. Then we extracted the keyframes from the video. We created a bunch of frame files. We haven't seen that yet. Then we get a list of the file names. And then for each one of those files, these are images for that given chunk, right? There's no way there's not going to be an image. There's just no way.
Yeah.
Like
there's going to be.
That's impossible, right? So we're reading the image, we're embedding it. And then for each of those keyframes, essentially, like he called it frame. Maybe that's a bad name. Maybe we should have called it keyframe. And the reason I'm saying that is because that's what that's the language we've been using this whole time, right? Right? We've been using the language, a keyframe. Would help if I renamed it properly. We've been calling these keyframes.
Yeah.
And we know what a keyframe is. Given a chunk of 15-second videos, they are images related to what we're seeing in there, right? And so he even called this function extract keyframes, right?
Yeah, extract keyframes from video.
Now, he calls this get files from a directory, which is fair. Maybe he's written this in a general way, right? But I still would have called this then what? Not just files. Keyframe files.
Okay.
Why are we this is why I got confused when I was asked that question, right?
Yeah. Okay.
So keyframe files, right? Fine. That's the file name to that file. I'm okay with file name there.
Yep.
Okay. These are all the keyframes. And then we went in and we read the file. Or I'm sorry. We read the image. What is a file? So we read it. We got an embedding and we produced that. So now we have a set of keyframes. Then this is really the unique keyframes. I'm okay with variables that are a little longer if it's going to help us not get confused when we're reading the code. I don't want Java level variable names. Okay.
Yeah.
Like we could have called that K frames. It might have been enough. It may have been enough. I don't know yet, but I know that there's no issue here. Now we could is that enough for us to say sort of unique? One strategy in naming something a little bit less is to get rid of the vowels.
Yeah.
Now, this word starts with a vowel, so you sort of keep it. But does that sort of say to you unique? It could. It might. We could play with that, see if we get sort of confused by it. But I think right now that works. We got rid of a few letters. We tightened it up a little bit, right? So for keyframe frame, we can now add that frame to, now, should this be called frame though?
It should be more to keyframe.
You should stay consistent here, right?
Yeah.
First set of keyframes, here's a keyframe, and then we take this keyframe and we put it into this unique sort of keyframes. I think it works. You know, tomorrow we might read this and feel like maybe that's too long or something. But so far, this is so good, right? So I would even argue this, like, is duplicate.
Is dupe. Yeah.
I think,
Yeah,
I
that
think
works.
all of us would know what we're trying to say there, right?
Yeah.
So now what he's doing, and I'm gonna put a line space there because I'm not sure. It is sort of tied to this, but let's just do that for a second. So we're going to range over the unique keyframes starting at the beginning, right?
Yep.
At this point, one would argue that we've done one. We're now on the second one. I is not 0. We have 1 in there. Now I can kind of understand why he called it previous frame, but that wasn't really accurate, right? It's not previous framed. It's this current set of unique frames that we have that we want to iterate over. So what's a better variable name for that? It's all the frames that we've decided to keep.
So it'll be like unique. Well, where do you previous unique frames or previous key
I don't
frames?
want to use the word previous because previous sounds, it's not really in line with this, right? This is a frame that we've sort of decided to keep, right?
So it's already okay. Kept frame.
So we're going to range over these unique keyframes. Maybe what we need to do is call it this.
Unique frame. Yeah.
Now,
which would match unique keyframes. Yeah.
we could. I don't think there's a name clash here. Why don't we do that?
Yeah, and that matches
Stay
what we
consistent, right?
exactly.
There's unique keyframes range. We get a unique keyframe. Then we're going to check the similarity between the unique keyframe that we've set as unique and the current keyframe that we're sort of looking at, right?
Okay.
We run our own cosine similarity, and then there's a threshold number. Now,
Yeah.
threshold number is 80%. Now, this is saying that we're not using dimensions anymore. So we're going to have to figure out how that happened. But we'll get there in a second.
I thought that was being used.
If that was being used, it would have been used here with the embedding. So what's got me confused is, oh, no, okay. This would have returned in the dimensions. I think because we're not using Mongo, where we're trying to create an index that specifies a given sort of dimension, because our cosine similarity is going to check that these are the same length. We probably didn't need to specify it. Anyway, what we're doing is check taking this keyframe and checking it against all the ones that we've currently set are unique.
Yeah.
If we do if we find something that's 80% or greater, then we say it's a duplicate in that list. We break out of the for loop. Now, here's something interesting from a logic perspective, and I'd love to get your readability on this.
Mm-hmm.
So either we're going to go through this entire list,
Okay.
and this is going to be false, which means we're going to add it. That's fair, right? Add the keyframe to the unique. Or we found a duplicate, we set that to true, and we break out of the loop. Now, there is something else we could do. Because ideally, I don't know if this is more readable, but look at what this code does. What it says is, if I find something that is similar, then let's continue the next iteration, but not for this for loop.
For that one.
For this for loop. From here, it's like a big go-to with a label. From here, go back to here. We never hit this code. We only hit this code if that for sort of burns out. Right?
Yeah.
I've reduced, I don't need a variable anymore, checking if there's a dupe or not.
Yeah.
But the syntax, so let me say this to you. 99 out of 100 times when I see this, I feel like we're doing something wrong.
When you see this syntax.
Yeah, it's rare that I code it once a month, something comes up, I think, and I see this and I go here, and then my brain says, I think I find a way out of it in some form or another.
Okay.
But I don't see a way out of this sort of right now, because the idea here is that we have to go through the entire loop before we identify that it's a unique frame. It's not like at any given time in the loop, we decide that life is good.
Yeah. I don't know if I like this syntax better. I mean, it is less code. I don't know. I feel like the not.
See, the thing is, he does a break where he's like, I don't need to check anything else because at this point, I know it's not unique.
Yeah.
And what I really need to do now is check the next frame.
Yes.
So I'm going to continue on, but I'm going to continue from here.
Yeah.
Right? And now this, if I ever get here, this is where I'm at.
Yeah.
And it saves, I mean, again, this is not the reason why we're not as fast as we otherwise could be, but it's interesting, right? I'm always, you know, they added that to the language for a reason. It's a clean way of saying go to.
Yeah, basically. I mean, for me, like, I like how this is sort of cleaned up too, but I also think skimming, I'd mischeck maybe. Like if I was quickly reading through it, maybe I'd have to like, oh, hold on, continue check. Okay.
So if I did this, which is also valid for consistency.
Yeah.
Right?
Continue back to check.
I wouldn't necessarily have to say check there because that's the loop I'm in.
Yeah.
But maybe for consistency, you would see, I would love for the few people that are watching this, what their thoughts are in this syntax. Do you think having a Boolean variable that has to be reset and checked at the end, cleaner? This is the first time in a long time where I feel like this works. It's the first time in a very long time where I'm looking at this and I don't want to get rid of it.
Yeah, I mean, I do like it for this. Maybe I'm just not used to seeing it as much. So the other way just feels more familiar.
Yes, and sometimes that's better for the team because they're not going to make mistakes. Yeah, it's a fancy look. This is what I'm doing.
Yeah, basically.
It's a go-to, right? Go has go-to, by the way. That's essentially what that is. Go-to check, but in the context of a for loop, so it does the iteration.
Yeah.
Instead of a go-to, I would imagine would start this over again. I have never used go-to once, but it's in the context of a continue, so it will sort of reiterate again. Let's keep it.
I like it.
It's the first time I don't think I have any code that potentially does this, although I've written it more than once. I've found ways to pass it back. Yeah, don't use the go-to. I don't think there's a reason for it. You have to remember something too. The Go team has to write Go code for really low-level things like the map implementation. If you were to look at the map implementation, there's more unsafe pointer work there than probably anywhere in the code base. But it's because they basically have a problem in front of them that really requires C. But they have to use Go for it. And so that go-to is there because they have some problems that, well, originally the language was written in C anyway. But, right, it wasn't until 1.5 that everything was written in Go. But they have, not us, problems where C is a better programming language, but they have to do it in Go, and they need every once in a while these constructs. We shouldn't be using them.
Makes sense.
But I feel like this works here.
Yeah.
This works here. All right. And I think that's a great point. If we couldn't put this code on the screen together, then I think it wouldn't work. I think it wouldn't work. I think that's an amazing, amazing part. And that's the part about engineering, right? Readability is, it depends like everything else. And so I think it works here because we can see it all.
Yeah.
Where Alexandra, if I'm saying you're right, or Alex, is right. If we can't see it all, it probably doesn't work in terms of readability. All right, let's just keep it. So I think this is a guarantee.
Yeah.
And I think allows this to have that guarantee. There is no guarantee after that on the append. So now we go through the unique keyframes that we have. And it looks like I just sort of logged it just so we could see this, right? This is step one. Now I would do this again here, right? Now we're going through the unique keyframe.
Yep.
Again, and this time we're going to get descriptions for the ones that we're keeping. Okay, fine. So now when Florin first wrote this, he was trying to be really efficient. He was trying to like do all of this in the same loop as the descriptions.
Okay.
And I said, stop. I go, let's, from a readability perspective, I don't care if it takes a tiny bit longer because that's all we're talking about. Let's break this up into the things that we have to do.
Yeah.
So here we just need to find the unique keyframes. I get that you have the unique keyframe now, and you could put underneath this line of code the calling of the chat completions to get the description. You could do that. But all you're doing, and again, to Alex's point, is that you're extending the size of this function, which now begins to eliminate understanding and some readability.
Yeah.
This is nice, right? And until that inefficiency is a problem, it's not a problem.
Makes sense.
Right? It's not a problem. And so one of the things we could also be doing in here to help with readability, right, is something like, okay, iterate over all the keyframe images that we extracted from the 15-second chunk, right? And I shouldn't put 15 seconds there because I could change.
Yeah.
But now, right, we're going to iterate. So there it is. We know what's happening there, right? And he went over those things, but so now it's read the, it's not the image files so much, right? Read the keyframe. Now, you see what's also hurting us here. This is the keyframe file.
Yeah.
Leverage this. We're not leveraging it properly, are we? Again, he's hacking. I'm not, but this today is, I think this code's been fun because we can go through and sort of clean up things that we're seeing.
Mm-hmm.
So read the keyframe and get the image data. We know that, right? Now, again, even though we've got those comments, right? What are we doing here? Okay. Create an embedding vector for the image. We will. I loved where it went. We will use this too. Come on, I loved what you were giving me there.
Find the most similar ones. Perfect.
Right? Beautiful. Right? Now we're not guessing. We know what's happening here. I love these little section. This gutter's in the 80 column marker.
Mm-hmm.
This is 120. If you keep comments and for the most part code in this 80 column marker, whether you're doing a presentation, whether somebody's on GitHub or in the browser, that code is going to be visible to everybody, no matter what you're doing. That's why I have that gutter there. And that's why, I mean, there are times where I feel like it's okay. You don't want to go past 120. Yeah. That's a little too much. Even like one letter here for me,
yeah,
I'm
there's
I'm
not
going to
much.
keep it, right? Instead of the little gap. But, right? And now what we're going to do is, okay, store the keyframe. Maybe I'll just call it information. So here we are, right? I've got this. Now, again, we're sort of iterating over this here, right? This is a loop. And I would argue now that what this comment isn't enough, right? Iterate all the keyframe images we extracted from the chunk and collect the information. We can filter out the duplicates.
Most similar. Yeah, duplicates.
I like duplicates better, right? So this is much more. Actually, I can even move. I don't know why I can't type today, but sort of move that here, right? Because that's what this whole sort of section is doing, isn't it?
Yeah.
Right? It's doing, that's what we're doing there.
I'm trying to collect information.
Right.
Filter out yeah.
And even this, I don't think he clearly sort of. So you see how this goes way out? I like things being on one line, but that would keep it inside of the. Now, I don't like when people break up function signatures.
Yeah, that it is.
I have a hard time reading it because watch sort of what happens. Like this first line, I can't read it.
No. Yeah.
Now you're going to have to do this. And I don't know, my brain isn't tied to that sort of situation. So I'll eat this all day long and maybe ask myself, and I don't care about, I wouldn't argue that there's too many parameters there. I wouldn't necessarily create a new gorilla to shorten this. Okay. Okay. But from a readability standpoint, I have a hard time with that curly bracket not being
on that first
that line that's sort of visible, sort of there for some reason. That's me. I've been on some projects where people do that and I have to keep it. Like that's what they do. Okay. And it's not about me at the end of the day, right? So, but I'm okay with this. if we think it's a little bit more readable and you have the line spaces around it, I'm okay with that.
That makes sense.
Remove any existing keyframe files from any like previous run, right?
Yeah.
I mean, that's what he's doing there.
And I like having comments like this. Like I know some people get like, you know, just seeing the code and it is what it is, but I enjoy the comments.
I like doing it this way as opposed to dropping comments on code.
On code, yeah.
I feel like if you're dropping comments on code, we're not in general, if we're dropping comments on code, we're not naming things appropriately.
Yeah.
Now, I'm not saying there are times where you're working on something that is sort of complex or convoluted to begin with, and you have no choice.
Mm-hmm.
But you can, this is a very long function name, but that to me is better than the comment. I'd
Okay.
rather have the longer function names have flexibility in being long
Mm-hmm.
as opposed to variables, because variables are used more than once.
Yeah, they're all
But a function is used once. So you can get away with a longer function name,
mm-hmm.
which eliminates the need of a comment as opposed to a variable. This is about as long as I want a variable to get.
Yeah.
To be honest with you. Because look how many times it's being used. 1, 2, 3. There it is. 3 times there. Keyframe files. Right? And so you have to remember that. Even this, how many times is being used? 1, 2, 3, 4. So the more it's going to be used, the longer it is, the more it's sort of getting in the way of logic. Where how many times is this used?
Just once.
You get away with it.
Mm-hmm.
You get away with the name of it. But these comments where you're breaking up, you have a function that really does all this work, and you just break it up in its sections, and you say, this is doing this. Now the code has context towards that. You don't need all the other little comments.
Makes sense.
So iterate over all the keyframe images that we extracted from the chunk and collect the information so we can filter out duplicates. Now we know what this whole section of code is. Now you might say, Bill, this is a really long function. Maybe we should take all of this and put it into its own function.
Mm-hmm.
Maybe. I mean, there's enough code in here where we could maybe make the argument. But what will start to bother me is that this is a function we're trying to what could bother me, not always, is, well, we only need this function once.
Yeah.
So why are we doing that sort of abstraction? But
that makes sense.
Since this is a process function, the workflow logic would clean up tremendously if we did break this up into little functions.
Mm-hmm.
Because now all of this function becomes like this.
Yeah.
And it's more readable in terms of the workflow, right? Maybe we should do that to also see the sort of readability of it once we're done, because there's a lot sort of going on in here, and we could really make the logic easier to read, right?
Yeah, definitely.
So, but let's clean this up first, and then let's break it out, and you'll see this might be doing too much to have this sort of detail in it. So what we did here now is we just collected all the information.
Mm-hmm.
And then here, so find and remove any duplicate keyframes. I mean, that's what we're trying to do here, right?
Yep.
By keeping the unique ones.
Yep.
Now, what this is doing is just logging everything.
Yeah.
I don't think this needs its own section because it's really tied to sort of the result of finding just for our sort of purposes on screen.
Exactly.
Right? Now, this section, this is code we haven't reviewed yet, right? Extract the descriptions for the, let's say, unique keyframes.
Yeah.
Now, like I was saying, we could have done that work after this. not start of iterate again. One could argue that we could do this in here, right? Because we're going to keep it, right? Instead of having this sort of reiteration. The question is, we're doing this for our brain.
Yeah.
Right. But maybe at the end of the day, the problem is if we were to do this, I'd have to also add a print statement after this.
Oh, yeah.
Right.
No,
You see, this logic starts to get sort of messed up. And so are we iterating again and doing that? Yeah, but this is already a cost anyway, just for our logging, and we're willing to take it. That's fine.
Exactly.
Right. As opposed to now I'm going to rewrite this logic so it always falls to the bottom regardless. And one could argue we could do that because this is going to be what? So imagine this, right?
Okay.
Just imagine this actually now that I'm looking at it. Now that I'm looking at this a little closer.
Length 0.
The first time we iterate over this,
Uh-huh.
this will have to be like this. We can't do it this way. If we do this, this new logic works. We just take the inefficiency of it. So, yeah. So I construct an empty slice. Actually, it's a 0 slice, right? It's 0. So we start to iterate over the keyframes that we have.
Yeah.
At this point, there's no iteration to take place.
Oh. Yeah.
0 length.
Yeah, there's nothing.
Right? There's 0 length. Again, I could be efficient knowing that there's always going to be 1. I could still do this. As long as the length is 0, this won't iterate. As long as the length is 0, there's nothing to iterate over. We know the very first time we've got memory related to this append. It's only on the second time do we need to, your battery's about to die, bro. When we need to sort of allocate any extra memory. Now, the chances of us only having 1 keyframe, I think, is slim. So this is a big premature optimization at the end of the day.
Okay.
But as we're sort of learning and teaching here,
you
see how we've cleaned this up even more because I'm guaranteed now that when I come here, we're going to have that. See, now, because of that guarantee, I could just do this. Okay. I don't need the extra loop anymore. And I could decide to do this. Now, I don't have a length, right? Which is fine. I don't necessarily need a length. And I don't even need a printf here. Just do print line. See, I could get rid of that.
Okay.
Now I've guaranteed that every time we add something to the slice, it happens here. So I can efficiently log here. That's not a problem. I don't have my length, but I don't particularly need it.
So now, why didn't that the if statement that was removed there? Why don't we need that now? Like it doesn't.
Because this for loop is never going to execute on the very first keyframe. That list is empty. So that logic is silly because we can do it here anyway. It's not like it was inefficient to check for that. Who cares? At the end of the day, nothing's going to happen anyway. So let there be one place. If you do things like this, you're also going to eliminate bugs. If there's only one place that something could be added to this slice, if that's not working, there's only one place to look.
Got it.
We had 2 places to look.
Yeah.
So there were 2 opportunities for a bug in that particular sense, especially when there wasn't going to be any cost anyway, because this for loop was never going to necessarily get executed.
Mm.
The length is going to be 0. Then we're going to have an append, and now it will be 1.
Got it. Okay, it'll be. Oh,
This is a
okay. Yeah,
premature optimization.
I see it.
I'm saying create a backing array of 1 because I know we're going to do this. The only way that hurts us is if there are no keyframes, which case the length is 0 anyway. So then we've allocated. Ideally, it would be beautiful if this was important and we spent time sampling, and we knew that on average every 15-second video resulted in 10 keyframes. I would tell you let's pre-allocate 10.
Okay.
Right?
Yeah.
With that length of 0. That way we're not creating all these little allocations 80% of the time or something.
Yeah,
we would need to do statistics because then you're sort of wasting some memory. Now, again, depending on escape analysis, this could be on the stack. It's not costing us anything, right? Because if the compiler knows the size ahead of time, it can allocate enough memory for 10 keyframes here on the stack, just like what the compiler's doing with that 32-byte buffer. Right?
Yeah.
Like how much memory is this? 16, 16, 16. Let's say 16, 16. So 1, 2, 3, 4, 5 times 16, which is like 80 bytes, plus another 24 bytes, right? 100 and something, and then another 24 bytes. So you're looking at 100 and, I don't know, I lost track, 140 bytes or something, right? And then you have to, it has to be a multiple of 8. But so whatever that number is, it's not a lot. Even if I did this, right? I'm saying allocate a K of memory on the stack, which is cheap. And I may or may not use it all, but it's a premature optimization here.
Yeah.
If I saw this in a code review and I just saw a random number like 10, we'd be having a big conversation.
Yeah, why?
Okay, why are we doing that? But you could see where this could sort of come in, where if we really do work and we know that on average there's 10 keyframes or we're going to keep 10 keyframes because we know how many we're going to keep here.
The length of
right. We know how many we're keeping here. This is just a matter of
here we're sort of making like a
but there are better ways to actually be more efficient because we're making copies of the keyframe, but we could technically just create pointers to this list, right? Instead of duplicating memory, one could argue that our unique set of keyframes could be pointers to the set, where all we're doing now is creating a slice of some pointers that point back, right? But these are not going to be our problem.
Yeah, we're not.
Right? So since we are going to make a copy, essentially, of our own copy of this keyframe, which is 100-something bytes, if the allocation was a problem, then I may do some pre-allocation on the stack and try to see if we can keep it on the stack. Again, we're doing cryptography algorithms and tight loops. These are games that you're going to want to play.
Yeah.
But for us, whatever, right? This is the more accurate way to go because this isn't a random thing. We know we're going to have.
Yeah, we know one. It's a guarantee.
Now, you could do what AI is saying. But we know we're not going to keep all of them. We just know we're not going to keep all of them. But this is interesting because we know that if we did, that would be the max amount of memory.
It's always the max
that we would need, okay, to keep. Now, again, does the compiler know the size of this at compile time? No. So a 32-byte buffer isn't going to be enough. There's going to be an allocation on the heap anyway. This actually works against us. As opposed to this could work for us because the backing array for this slice, now, if we stay within 10, gets to stay on the stack. You see what I'm saying?
Yeah.
So we're gonna prematurely eat a little bit of memory on the stack to
Save
reduce
it.
the particular cost of the allocation on the heap
Yeah.
in these small sort of cases. See what's happening?
Yeah, that's interesting.
But again, right now this is it's a random number. After we do enough work, if we see that on average we end up with 10 or less keyframes, I would put a comment there that says we've done our work, and let's say 80% of the time
It's 10.
it's 10 or less, right?
Yeah.
I would say to you then, let's take the optimization and keep things on the stack.
That's cool. That's interesting.
But we're so premature optimization now, right?
Yeah.
Until I run a profile, who says that's even my biggest problem, which it won't be, because there's other like crazy things we're doing, like waiting on an LLM and all the other stuff, right? But
Exactly.
you see kind of where it's going, right?
Yeah, it's an interesting conversation though for other
So you
projects.
can't put 10 here unless we do something like we have identified that 80% of the time we have 10 or less unique keyframes. 80% of the time we have 10 or less. So we're going to pre-allocate that memory to reduce the little allocations that are going to be occurring there.
Okay. 10.
We don't really know this
Yeah.
right now, but let's just, all right. So now we come in here, we have a length, right? Extract description. So now we're going to go, and these are really costly calls here. These are going to take time.
Well, the completions, yeah.
Yeah, we got to go and do that. So this is where that prompt, which is up here, sort of takes place, right? And so we've got a prompt. We also give it the image itself because we want to get a description of the image itself. This is where we're going to be using this new embedding. No, this was embedding. No, we're going to come back and use this model here to do the description. And that is the LLM chat model, which is this one that he found.
Okay.
Which is like it's a small 8 billion sort of model that handles images and is fairly fast.
Okay.
You can see the embedding model was that one that we, yeah. And, I have a lot of memory on this machine, so I have to remember that not everybody does. And we had to find models but it was accurate enough, right? That's what we're worried about, accuracy. So we're going to call that. We're going to get descriptions. We're going to potentially clean up any JSON hallucinations, which can happen because the model's been sort of cut in terms of its accuracy. And if it ends up being classified as an icon, we ignore it. And if not, then we update the description and the classification in that index position for that unique keyframe, which is fair, right? That's fair. Then he's sort of printing all this again, but I don't think there's value in doing this again, other than we get to see the classification, which we didn't get before. So that's fine. So let's just leave it.
Okay.
So this is this is all step one. We're basically given this chunk of video, which is, what do we say, 7 seconds, doing all the core stuff, minus the anything with Mongo or anything like that, right? All right. So this is example 13, step 1. Let's see what happens on my machine here.
Oh, it's a lot faster now.
Well, let's go back through this. So you see here we embedded, now that we can create these embeddings for the frames, we can see what frames we have. But so that whole thing sort of finished, though I feel like
Example
I feel like
frame
it's not working.
0, 0, 0, 0.
So
Checking them in.
similarity is 99%. We'll look at everything. We'll see what it finally decided. So it's decided that there's only one unique frame out of the whole list. And that's why we only got one sort of description. So let's take a look at the raw data and see what we get, okay?
Yeah.
So
output.
This is the chunk. There was only one chunk because our data had one chunk in it, right? It was 7 seconds.
Yep.
Now, here are the images that got created. So we've got this code. That's the same. That's essentially the same. The same. We could argue that it's pretty much the same, right? When we do the embedding. And if we come back here, we see like this is 99%.
Yeah, and it is going down as there was more, like a little bit more changed.
But you have to decide what that sort of line in the sand is. I think we decided 80%. So this wasn't a fun video. We'll play with the other one in a second. But now this is where we've got to get a little smarter, because if we look at this, which one was better to keep?
I think it was that one.
Yeah. So, but that might not always be the case. But one could argue in my training that the deeper you go into these images, the more code we probably would have in there.
Yeah.
Again, we might solve that problem though in the next 15 seconds.
Yeah, exactly.
Right? Because in the next 15 seconds, you'd get that anyway. So it might be a wash. But what's interesting here is that the similarity stuff worked in terms of picking an image. And then what we did is image shows all of this, right? Now this is a problem.
Yeah, classifying it as a terminal.
Because that wasn't terminal. That was source code. That was working better for me before. And so since it was a terminal, we didn't extract any code. See, below there are several lines of code.
Or commands in the light gray background. Yeah.
So I feel like the description in this particular case wasn't accurate enough, right?
Yeah.
Now, let's go back here for a second. How do I close it? Oh. Now, in that case, I was using this model here. What if we do it again, but I use that model?
OSS, okay.
Let's see what it sort of says, right?
Yeah. And then the description is going to take a little longer because
take a little
thinking model.
Oh, that model doesn't support images.
Oh, OSS doesn't?
No.
Or the other one?
It doesn't support the images, so it couldn't extract information. You need an image model. Now, I know that we had at some point a better, I think the Quen can work. Let's try the Quen real quick.
I think so.
Yeah. No, the other model is it's a reasoning model, but it didn't take images. I think this one will take images. But this one could take a long time.
Oh, yeah.
That was the problem, right? Even on my machine, like you'll be here forever. However, look how it classified
source code. Yeah, much better.
You see? It classified it as source code.
Displaying a code editor. Now it knows it's a code editor.
But because this model its legs aren't being cut out from it by downgrading the floating points and the all the other stuff, right?
Yeah.
So It's interesting, right? Now, one thing we don't do in this example, which maybe we do in step 2, is the code extraction piece.
Oh, okay.
Right?
Yeah.
So I think in step 2, it's this code right here,
And then,
which is right at the end, right?
yeah.
So I'm going to do the following for a second. I'm just going to hold this code in for a second. And I'm going to go to step 1. And I'm going to replace this code with step 1.
There was also a prompt too. I saw above
Oh, there's another prompt.
for the extract code, I think.
Oh,
Yeah.
yeah, I was going to lose that.
Frame info. It was that one, the extract code prompt.
Yeah, I need that too. All right. I have a little text window open that you don't see. So let me just drop that in there. All right. Now let me steal this code since it has all those changes we made.
Mm-hmm.
Put that in step 2. Okay. And then I'm going to come back and add the prompt back in here.
When you're doing work with code, like in like a normal project, let's say, do you prefer keeping the prompts like this, like in the same files of code, or in like a prompts txt?
I like embedding them sometimes. If it's a real production product, we're going to put them in a separate file.
Okay.
And
Yeah.
we'll embed them in, as opposed to what I'm doing right now.
Yeah, exactly. That was something I struggled with.
Yeah, I'm going to do that instead. Now, let me see. I think we have to do that inside that loop, I think. Let's see. Yeah. And I didn't add code to the frame. I probably got rid of that too. Code string, right? So,
And then
so once you get the text and the description in this thing, right? If the classification is source code, now we'll use the LLM chat model again.
mm-hmm.
And we don't really have an F here. We're using unique keyframe. Ideally, this would be unique keyframe, right? And then we can put the code in there. Now, the question though is LLM response. Where were we sort of logging that? Ah, there. All right, so we had an LLM response for the description.
Okay.
Just so we can see it, right?
Yeah.
And maybe I'll just do this. I don't like the way we're logging anything, to be honest with you. I feel like if I come back here, it's just sort of a mess. I don't really see it very well. We can clean some of that up. But now I want to run this step 2 with the code. I'm going to keep the model that we're using. Oh, I was using it. I think I put it back. Oh, there it is.
Mm-hmm.
So, yeah, all I did was change out main or something. So I'm going to, oh no, I changed it here.
Yeah.
So let's use this same Quen for a second. We'll go back and check the other model out too, but let's do step 2. But this sometimes is the problem with doing everything locally because you just don't have the power. If I put this up in prediction guard, boom, that's what it came back.
It's a
came back.
quicker.
right? It was just bah, 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 bah.
And that's just because you're using like, bigger GPUs.
Yeah, bigger machines, bigger GPUs can handle it. But here we got source code. See, now we're extracting the source code. So when we want to do it for like ultimate service,
Mm-hmm.
you ain't gonna be able to run this thing locally, bro.
No, it's
right?
gonna take a lot.
But how cool is this? Because we got some code here, right?
Yeah.
Now I don't know if I would put this in a JSON document. In this case, I would just say extract it out.
Yeah.
But we did get, I don't think we got all of it, which kind of sucks.
No,
It gave us sort of this, right? So this would be more work to do. But also I think, like I would say I don't want the extract all the source code, do not include any other text, do not interpret the code in the image.
And then in JSON format.
See, I don't want to do this. Like, this is where kind of Florin and I disagree on prompt construction in this case. I don't need JSON here. I just want to dump, right?
Okay. How would that affect it though for doing? Oh,
It's code at the end of the day. It's
Yeah.
not like I have text and it's not like I have multiple things. Okay.
yeah, that makes sense.
I don't have all these other things. I just want the code, right? So if I do this, not everything has to come back in JSON unless you're asking for it to like take unstructured data and make it structured. I'm not looking for structured data right now. I just
you just want the
give
code.
me the code. I don't want to lose the CAD return line feeds. I don't want to lose any of that, right? So for the first one, it's fine because I had a classification and I had text. But this to me is just a code dump. So I don't think I want to play the JSON game there. Look how much better that response is.
Now it gave you everything.
Now, even though it gave me this, right?
Go. Yeah.
I'll filter that out. But I got a much better response when I told it just, you see what I'm saying?
Yeah. Don't try to structure the code into a JSON. Just give me the code.
Just give it to me because that's the only thing I want.
Yeah.
Right. And again, I see that I can filter those little things out. Look at what I have right now.
Yeah.
Got everything. The only thing I don't have right now is the transcription. But, and we've run out of time here. We've added a package here called audio that uses the Whisper CPP and has the Go bindings for it. This will let us extract the transcription. Transcription. Now we wanted to do it with FFmpeg, and maybe they fixed it already. FFmpeg version is 7.11. 8 has support for transcription.
Okay.
At the time we were hacking on this last week, there was a bug in getting FFmpeg version 8 out with, now, you see how it's there? So because we couldn't use it, even though we wanted to, we wrote an Go packet. Step 3 is using the package we wrote and adding audio descriptions to it.
Okay.
Now, when this is done, we're going to check FFmpeg version. If it says 8, we've got a big conversation to have. Do we use FFmpeg to do the transcription, or do we keep this sort of in the project and show people how you can use Whisper to do it? We don't need diarization. Diarization is when you identify different speakers.
Yeah, who's talking?
Right?
Yeah.
Which even the data that comes back for that is crazy. But If I do FFmpeg version, see, now we have the ability to do transcription with FFmpeg. They fixed it, right? It's here. So the question now is, we've written this code. This code works. If I go to step 3, I'm guessing I'm going to see that's the code samples. I didn't get rid of that message.
There it is. Oh, I saw it. Convert audio. Yep. Convert video and then audio process.
Which is at the bottom here. So let me keep this code for a second. I'm going to put it in my little text window over here. I'm going to go to this little function here. He used the wrong brackets anyway for that. Okay, so now watch. So he is using that at the end of that big function, which I still think we probably want to break into little functions. But if I go into step 3 now, put everything that was step 2, right? Okay. Extract code samples from keyframe. Now, if I add this function back into step 3, and ideally we don't want, I always use this at the outer. I use the single dashes on the inside.
Oh, okay.
Right, but with all these functions anyway, I don't think we need them. Like we know they're functions. I don't need to split this up. We'll clean all that up. I do this when we really need this is stuff I still have to teach. You know, what we could do is just this here, because that's the big function, right?
Yeah. Okay.
And again, I would say that none of this is adding value here. But this is just stuff I have to teach Florin in terms of. No. Watch you. This is where I want to put it, right? Everything else is inside of a function. I use the single. Outside of the function, I don't. I don't think we have any of this here. Yeah. I don't think it adds to the readability. But now that I'm here, might as well, because I'm going to check all this in. You can even see he didn't get to 80. But here, we kind of separated the big function, right?
Yeah.
So we're adding the convert. And now what I can do, come back to this really big function that we should sort of clean up. I don't know where we put it. Hold on, let me see what we got here. I need the audio stuff to it. Okay, I'm going to get it. It's no big deal. And then we do the transcription. I should really put this code here. All right, let's just go into step 3. Oops, did not mean to do whatever I did. Very impressive. I meant to move this. Yeah, step 3. And just get a couple more things. So I need you. I need you.
Audio.
Again, we're hard coding some sort of settings in here for our audio. And I added code to that already.
There. Yep.
On run. I did that here. Probably I didn't put a line there. That's fine. So we did add under Zarf audio that's under samples. So audio. This is a tiny model that's used by Whisper.
Oh, okay.
All right. Now where did I put? Did I not? I must have a variable. I don't see where. Is this in the big function, I guess? All right. Oh, process chunk. Okay. So in process chunk,
It was
doing this all bad.
audio.
Yeah. Where did I put it though? After LLM embed makes sense. So we'll do that. Whoa, 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 whoa. Okay. And then in process chunk, we ask for the audio here. Okay, perfect. So that takes care of that. Now, you're complaining about what? Oh, no new variables. Fine. How do you like them apples? So there we go. So now, okay. So now what we're doing is constructing our new audio API from our audio package using this model. Pass that into our process chunk. And now what we've got under process chunk is this last section here. Okay. Now, the question is, we want it out here because we've got the full path, right? It's outside that loop, right?
Yeah.
Just double checking full path, which is, where's full path? It didn't complain.
I thought it's full path up there, the 176.
So that's the full path to the chunk, right? Okay, sweet. So now what we can say is extract a transcription of the audio. Nice. And then we'll see what that is.
Okay.
Okay. So now in step 3, we've got sort of everything. None of the Mongo stuff, but we should have sort of everything. And then ideally, got the code, and then we have the transcription, right?
There it is. Yep.
And then we would follow the same sort of thing we did here. But we gotta put it into the object. It's not a
higher up.
Keyframe file.
Not 245, right? Or
it would have to be inside this I loop. Ooh. Think about this for a second.
Unique keyframes I code.
It'd have to be unique keyframes. Sub I, like we did here.
Yeah.
But these are the images, right? This isn't the audio. The audio is at the, this is interesting, right? These are the keyframes.
Yeah, it's more at the chunk level.
So right now I don't have a place to put it, right? It's not here at the keyframe.
No, it's in.
We don't have a place to put it yet. And that's why I think step 3 stopped where it did. So we'll just sort of do this for now, and then we're done anyway. But let's now run this for step 3 and see if we get that final audio chunk using this audio. We could switch that out for FFmpeg too, though, if we wanted to.
It's
okay. So it looks like my project, I know I ran this. Something didn't build here. Oh. I might be missing. No. That should have worked. Maybe I got rid of something.
The require or.
Now I gotta ask Florin. No, that should have worked. That should have worked. There wasn't anything here to do. It could be a makefile problem, but I didn't change anything in the makefile.
You did do an update though to FFmpeg.
Yeah, but that wouldn't have. Well, this would have affected FFmpeg. No, because this wants to use. I have to ask Florent. That shouldn't have happened.
Foundation.
This has to do with building of the Whisper.
Yeah.
We have to point the system to some C libraries that we have in here, not under Zarf, obviously. Well, you see, we've got libraries here that we make as part of the project. And then in order to run that, if you look at audio and foundation, audio Darwin, you have these C flags and these LD flags, which I don't know why it's not working because I used to do it out on the makefile side. But we are running Darwin here. So what's telling me is it went to something happened with C-Line. Okay, I'm not going to be able to run it. I'm going to have to ask Florian why this is suddenly failing for me when it wasn't failing before.
Clang error, unsupported option.
Yeah, we changed something here. And I don't know what it is. But this should be working without a problem.
Huh.
So I'll get Florian involved and then we'll figure it out. But if we used FFmpeg, all this sort of goes away. But
yeah,
ideally you need, and I don't think this is the problem. I think it found everything. It found all the libraries that we have there in that source folder. For whatever reason, oh, I bet you this is not helping. No, that shouldn't matter either. No, that's not going to matter, I don't think. Yeah, that shouldn't matter. I don't know enough, and there's no way I'm going to fix it now at 1 o'clock after the show is over. But that shouldn't necessarily be. See, what I would normally have done is I would do a go build, and then run it. But we made these changes where we put this in here to make the go run work. Like we put these settings in this code file, and then that allowed go run to work. When you do a go run, it creates a temporary folder. You see the object files.
Yeah.
And then it's going to execute this stuff. But what seems more interesting to me is this F, right? Saying unsupported option. And I don't know why that happened.
Oh, that one.
Like suddenly. And I'm not gonna go down this.
Yeah, that seems like a rabbit.
I'm gonna get Florian involved. But what's interesting is this was working for me last week for sure. Oh. That feels old.
Clang.
That feels wrong. That feels very wrong. I think that should be updated with the brew version, to be honest with you. So I have to look that up too. I think I shouldn't be using, I wonder if,
No available.
well, I can do brew install cask clay, but I don't know that. Like, I don't know what that is, right? So
yeah,
we could try this real quick. If I just give it another install clang. I feel like probably not running with the latest version.
that's on Xcode.
Oh, but Xcode obviously I already have.
LLVM includes.
Let me see what version I have. Just what do we think is the latest version of Clang? 21. I'm at 17.
I'm also at 17.
Let me do this. I thought I did this already though. Yeah, you see, I already have LLVM. So I don't know. I'm gonna have to talk to Florin. This wasn't a problem before, and I don't know enough. It's interesting though. All right, we're not gonna solve this problem here. I just was shocked that it's using that because that's like Mac Apple level, right? Like that's all.
Yeah. Huh.
But I don't know enough, bro. I just feel like something's wrong. But that's okay. I'll get Florin involved and we'll figure it out and I'll have that fixed. But for sure that wasn't happening to me before. Now, maybe I'm missing something. Maybe I didn't run this before. So either because Clang is so old, it doesn't sort of support this. But I do have LLVM already installed because we needed that for other things. So it's all very weird. If I go to the PG project and try to build this, which is where we use it, I don't really have the problems. That being said, audio service. In order to run this stuff, you see, I do all this stuff here. Hold on. You see all these settings?
Yeah.
See how I'm pointing
Clang.
it to?
Oh, and LLVM, homebrew seller.
Yeah, these are not set. So I bet you $1 million that if I do the following, stop trying to help me. In fact, I'll move these down here. That's the problem, right? It's using the Mac version instead of
the brew or LLVM.
Yeah, which if I double check what version I'm running, I got to tell Florin this. 21.10, 21. So even this, I have to. There's better ways to do this, okay? But let's just say I did this. I bet you now it works. So this is something I'm going to have to show Florin. Yeah, right. It was using the wrong version of Clang for me.
There we go.
I hate C, bro. It made the shit so complicated. So I used to have to put all of this, even the Seago flags, in the make file. But Florin showed me that I can escape doing those two by putting these here. Now, I wonder, though,
you could do the same.
If we could take these two, put them in here as well. I don't know if they're C flag. Like, they're not necessarily C flags. They're just, right? They're not C flags. I have to ask Florin.
Yeah.
But unfortunately, Clang isn't, yeah. I'm going to ask Florin how to solve this problem. But you see, I need to set those variables. So the compiler uses those versions of, what sucks is every time I do a brew update, this sort of gets updated. And I don't think there were symbolic links to that, is the problem. So what happens is, like it just drops this version in there and I don't know enough. This is where like having Florin's gonna help because I don't know enough to deal with that. And I hate fighting this stuff. Like, this is like all settings. Not what I want to be doing with my life. So where was I just before? I was in Seller VLLM, right? Oh, LLVM. So every time a new version comes in, that version number changes. So most likely like I don't know how to deal with like this is where my Linux foo starts to like drop off. But whatever. I set that now. I'll talk to Florin.
At least we know what it is.
And here's the audio chunk.
Whether we like it or not, the server mux. Oh. So now, and that's linked to that chunk.
Yeah. So we now have the full. I gotta talk to Florin about this, but
yeah. So
we now have the full right by at the point here of step 3. And I think all this should just be in one step, just because from a teaching perspective we could break it down.
Yeah.
But because these last 2 little pieces, they're all the same, really, right? I'm probably just going to make this all step 1. And fix that when we're done here. But now we're using the Whisper, and we get the full transcription for the entire chunk.
Got it. And the audio transcription is completely like independent of the
frames.
The frames.
Frames
it's a different thing.
We're just trying to find code like we did.
It's just tied to the chunk. Like those frames are tied to the
So if you really look at this now, we've got everything, right? We've got the proof of concept. I've got everything. Now it's a matter of taking the larger video.
Yeah. And
right, which we'll do on Thursday. And well, really the next step now is storing all this stuff in Mongo, because I want to store the images with it. I want to store all the metadata in Mongo, right? Where am I going here? Oops. So I'm going to save all this stuff. In fact, I think 3 is just going to become 1. And
I think so, because
I know they're
just like
it's all the same little thing. With that diagram, I'm going to move under there and clean that up, so we know exactly what we were trying to do, right, in every step, and we have it. And so that's step 1 is our proof of concept. We can get all the data we want out of that video.
That is super interesting.
In 15-second chunks.
Because it's not just the transcription; it's also all the images, like, all the code. That it's like endless where you can kind of do it that
well, now we've got the real information. Now it's like the book. I mean, that's what we took out of the book, right? And so now I think you'd have a proper sort of chat system with proper RAG information. So I'll clean all this up.
That's super interesting to see all the chats.
But now the big thing is to take on Thursday the larger video, and right? But the model is, you saw how the other model didn't categorize things.
Yeah, so
I got to talk to
the model.
Anyway, we're way over now. So, all right, everybody.
Okay.
Thanks for hanging out. I'm going to clean all that up. You can look at 13. Give me like an hour or something. We'll clean it up, and then on Thursday we'll continue to try to do this at a larger scale.
Yeah. Do you think the machine has enough to run it?
Well, step 2 is to take that, put it in Mongo. There's some things I don't know how to do with Mongo just yet, like the images and stuff. So that's going to be Thursday. I'm not going to try to do any of that work ahead of time. That would be step 2. Then step 3 is, can we
do a full-size video?
That 45-minute video. And then from that 45-minute video, can we use our chat app and start asking it questions and get code back?
That's going to be crazy. And then even just linking to the
and getting the link back on the timestamp. Yes. Yeah. And then bringing that up.
That's super.
That would be like next week.
Yeah.
But you got to get it in Mongo first now.
Definitely.
And just for this 45-minute video.
My head's already thinking like UI side, like how.
The UI is the chat app.
Yeah.
I already have it.
Which I've been thinking about, honestly, like I could do more improvements to that now. I know a little bit more.
We'll see where we're at. Anyway, all right, everybody. Appreciate it.